Hi, everybody. Welcome to the DevOps Patterns, Anti-Patterns track for DevOps Online Summit. And, we have Stephen Magill with Muse Soft, or it's just Muse, isn't it, Stephen? With Muse.
It's Muse and now Sonatype. We were acquired by Sonatype last week.
Oh, that's right. Yes, congratulations on that. That was really cool to see.
Yeah.
And so Stephen and I have known each other for a few years. I'm really excited. Thank you so much, Stephen, for volunteering to do this. I'm really appreciative. So what are you going to talk to us about?
Yeah. Thanks for having me. So yeah, I'm really interested to, maybe start by just, continuing a conversation that we've had a few times in the past around metrics. And, I'm particularly interested in metrics as they relate to software analysis, the analysis of the software itself. So what can you determine that's useful to track when it comes to, the actual code that you're writing, the code in your repository. And, that's sort of, I guess, grows out of my interest in code analysis generally, right? And how can we help developers build better software, discover errors faster, be more productive, while also meeting, various organizational security and compliance and audit requirements. So yeah, I think there's a lot to touch on there.
Yeah, well, and how did you, we all have our passions. How did you get into the code analysis problem space?
Yeah, I guess, it's been an interest of mine ever since, since I was first studying computer science, in undergrad. The idea of like analyzing software sort of as a mathematical artifact, that was very interesting to me. And so I, studied that. That was sort of my focus area in grad school. The topic of my thesis work ended up being static analysis. I think that it's this nice interplay of, reasoning deeply about code. A lot of these analysis tools, they build models of what is the software doing and then try and use those to determine, issues with the software, ways to improve it. But, it's also, because it's automated, because it's, in many cases, efficient and scalable, like, you can have a lot of impact, right? So, there's sort of various ways to approach analysis of software, and static analysis ends up being sort of one of the most broadly deployable, most high impact ones. And so I guess I was drawn to it for that reason.
Yeah, that makes sense. I know that I've always appreciated finding out early that I was breaking things, for sure. And so metrics, I think it's a huge passion for both of ours. The things that I focus on metrics are slightly different than what you focus on daily. But what are some of your favorite examples of metrics you found useful and why?
Yeah. So I think, there's there's a lot of metrics that are commonly tracked, and I think some are more useful than others. You see, discussion of lines of code as, I don't know, sometimes a good thing, sometimes a bad thing, but I think more often just a not informative thing, right? Because there's so much beyond just how much code there is, right, that you need to take account of.
Yeah.
But I think some that are more useful, that I think are reasonable to track, and relate to what I was saying about static analysis. A common first thing to do when you bring in a new tool is to say, how many findings are there, right? When I run this tool on this code base, how much stuff does it find? How does that compare to how much it finds in this other code base? And, I think those are potentially useful, to the extent that, well, it's sort of similar to other measures like backlog, how large is the backlog? What's in your issue tracker? How long do things, stay in your issue tracker? Like those sorts of metrics around, here's a list of things that, probably if we had our choice and we could, address whatever we wanted to, we would, get rid of these issues. We would address all of them. It makes sense to track that to see, how you're doing there. But, I think, it's what's really useful is tracking that over time, right? So, there's some baseline. Every code base has some baseline for, you run a new analysis tool on it, it's going to find something. And, just the fact that this tool finds a bunch of things in this code base and not a lot in this other, that can be as much a commentary on the tool itself as on the code bases, right? Different tools have different focus areas. And, but, in the context of a particular code base, it certainly makes sense to look at that metric and track it over time. And, you see people do this and say, we're going to have an initiative this quarter to reduce the bug backlog by 10% or whatever. And, I think those are sensible activities. I think, one thing that's interesting to me is sort of how can you get beyond the sort of correlational analysis where you say, okay, we want to reduce the bug backlog by, 10% this quarter. So we're going to institute these practices, right? We'll reserve a certain amount of sprint capacity each sprint to, working down the backlog. And then, so we'll institute that and we'll track this. And then, you see it improve, but, there's probably other things you're doing too, right? Like you've brought this tool in and maybe it's integrated in some way, maybe it's commenting on code changes or it's integrated in the IDE, and so like to what extent is it this practice versus that practice that's contributing to that effect, right? And I think there's interesting metrics that aren't tracked as commonly that sort of give you insight into that. And so, one that we track closely at Muse is fix rate, which is, so we point out errors in the code review process. So, tool finds an issue with a code change, you submit that as a comment in code review, and then the team can deal with it, triage however they like. And so, one very informative thing is, did that error get fixed before the code was merged, right? And so if so, we call that a fix. And if not, it wasn't fixed. And so we track the percentage of results that get fixed, right? And that's what I like about that. And I think there's other metrics that we could explore in this space too. What I like about that is it's a direct measurement of that intervention, right? So you have a tool that's integrated into the process in a particular way, and you're directly measuring the impact of having that tool there, which is sort of, I think, takes a step beyond just saying, we introduced this tool and we saw this thing go down, right? You're sort of directly measuring the impact.
No, I think that's actually touches on a really good point. I mean, people, I don't think dig deep enough into what metrics actually mean. And this is a really good one for the value of that particular tool, right? Is that, we're doing a thing, we're seeing change, but how do we know that the thing we're doing is causing the change? Right. And identifying before you start doing that change that this metric will change, I think is really important and often overlooked.
Yeah. And so, I think you can track similar things with, like if you're trying to use, the issue tracker as, you're tagging issues as sort of high priority, and then you have a process in place to sort of devote some time to high priority issues, sort of tracking separately, how quickly do those get fixed, the remediation patterns around that, again, lets you directly measure that intervention, right? I think it's important to, it's important to get that high level sense of, are things improving, are they not? But then the more you can understand about why they're improving and what's contributing, the more efficient you can be in spending your time, right? If you find that this practice has, a huge effect on some outcome you care a lot about, and this other one not so much, then, you know where to spend your time.
Mm-hmm. One of the other things that I've seen, I'm sure that you've seen, is people grab a number. They don't really know what the number means, but they like that number, and then they start applying that number, even if it's a metric that's, useful in some other contexts, and start abusing it. What are some of your favorite examples of that, and what not to do?
Yeah. I mean, I think one is that example from before, right? Like, how many bugs does this tool find in this code base, right? That to compare that across code bases is maybe not a useful thing. It's more useful as a number for a particular team to track in the context of a particular code base. I think there's a lot of metrics actually that follow that pattern. It's useful for a team to track this metric over time and see how their number is changing, right? But comparing across teams is maybe not so informative. And I think that's the way I most commonly see metrics misused, right? Is a way for grading teams against each other and saying, oh, you guys aren't keeping up, right? But I think, those comparative things can be useful if you sort of set the right context and deploy it in the right way, right? So like, to go back to the example of fix rates, right? If you can show an issue to a developer and say like, 90% of developers who see this result choose to fix it, right? That's a nice signal, right? It says this is probably important. The community at large, seems to feel like this is important. I should pay attention to it, right? If you say your team's fix rates are, 40% and this other teams are 60%, then I don't know. That rubs me the wrong way.
Yeah, me too. And it's possible the team knows what's best. And this actually brings up another point that I get asked. I've been asked quite a bit over the years by developers when we talk about coming from the platform, and when you're sending them static analysis results, and they're being driven to fix every single thing that shows up in static analysis.
Yeah.
Right. Have you seen that? And what's your opinion on the value of? I mean, blockers and criticals, that sort of thing. So that's obvious. But what are your opinion about the lower level?
Yeah. It's really hard to set some sort of blanket policy like that because different tools are just so different. I think you have to understand how first of all, no tool is perfect, right? So there always has to be some escape hatch, right? But even if it is, most result, we want every team to fix at least 90% of, what comes in or whatever, that makes sense for a tool that is tuned to only report high confidence findings and so forth. And so that's the approach we take because we are in front of developers and part of that code review process. We don't want to be just throwing a bunch of stuff in there that, might be an issue some of the time and gets ignored the rest of the time because then, people lose trust in the tool, right? But that's maybe how you want to tune things if you have a tool that's sitting sort of farther at right, sort of as a gate on production releases or something, or the security team is applying this tool to make sure that they absolutely, as much as possible, catch all, SQL injection attacks, right? So, there maybe you want a very fine filter, a tool that's tuned to flag anything that it thinks could even, potentially be an issue. And so you can't apply the same policy to both of those tools, right? And I think that's something that's often ignored when you see policies like that of we just have to fix everything, right? And it can have a huge developer productivity impact, right? If you're spending all your time just addressing those issues.
Well, actually, that brings up another something else. I think is if people are pushing on this metric and it's impacting developer productivity, right?
Yeah.
What are some good ideas for measuring something else to try to prevent that, so that I can say, hey, as a manager, I'm doing something here that's actually hurting the team, and I need to know that. I need that feedback.
That's right. And I think that's sort of if there's an art to applying metrics in the right way, that's one place where it manifests. You don't want to just pick one metric to try and focus on and improve, right? You want to, flag that primary metric that you want to improve on, but also think about the potential negative impacts that it could have, in other aspects that you care about. And then think of ways to measure that to make sure that, you're at least not hurting, those results, negatively impact productivity. Or if you are, you understand how much and it's a trade-off you're willing to make, but again, too often people just measure one thing, right? And then you lose that visibility into the rest of the impacts.
Yeah, like code coverage and velocity.
Yeah. Well, there that gets to what's your favorite developer productivity metric?
Exactly. Yes, that's actually something I have conversations about quite often.
Yeah. That's a tough one.
Well, you were talking about detection left and detection right. How everyone's trying to push detection left, right? We want to find out things as early as possible, but there's a limit, right? I mean, how far left is too left?
Yeah. Well, I just let the system write your code for you, right? And then that's as far left.
Exactly.
No, I think it depends. I'll say it depends on sort of the technology. So I'm a big fan of the checking that's in modern IDEs, where you make certain mistakes and it's the spell check underline, right? The squiggly underline, you did something wrong, or an exclamation point immediately appears and you can just deal with it in the moment. I think that's that's really useful. And the problem is like not every sort of check lends itself to that sort of real-time feedback, right? So like if you think about like I mentioned SQL injection attacks before, right? Those require a deeper understanding of the code. They require understanding sort of where data, potential attacker controlled data flows into the system, how it's processed, and then what the endpoints are that are dealing with SQL databases or constructing queries. And so that analysis just takes time, right? It can't be done sort of instantly on the developer's machine. And so those sort of naturally can only go so far left, So like we focus on code review as one place where you can do some deeper analysis and have it feel instant, even if it's not, right? It's sort of like as long as the results are available by the time a human's coming in and reviewing the code, then it might as well have been instant. And so that opens up more opportunities. And then you certainly see tools that maybe take even longer to analyze the code that have to be run outside the development process, and that comes with its own trade-offs. But in that case, maybe that's as far left as that technology can go. I think there's it's also interesting to think about how the same analysis technology manifests differently depending on where you integrate it into the process, right? So like the squiggly underline thing I talked about in the on the developers in the developers IDE, that same technology can be used to check for if there's a team coding standard, a project-wide coding standard, to check for that in a pre-commit hook or in a in the CI process as a gate before code merge. But you have to think about that integration differently, right? So if something's going to block a merge, or something's going to be a pre-commit hook and block even pushing code, it has to be sort of only sort of very important things, right? You have to set a narrow aperture for what would trigger that sort of thing. Whereas in ID, maybe you can be more general. You can say things that half the time they're fine, half the time you should maybe fix it. You could surface those in an IDE, and it's up to the developer whether they ignore that instance of it or fix it, right? And so you can sort of be permissive, have a wider filter there.
No, that's actually going to lead into my next question, because you said something really important, which is it's up to the developer. Each one of us as developers, we have our own workflows.
Yeah.
But I see a lot of examples of people wanting to mandate a workflow onto multiple teams. You're all going to work the same way. And so, no, you have to have integration of linting into your IDE, and you have to correct those before you commit code, as an example.
Right?
Yeah. I know for a fact that there's people who they lose their flow of work if they keep getting interrupted by linting errors that they might want to pick up before commit.
Yeah, that's right. Like some people, some people want to know in the moment, and fix it then, and other people would prefer to batch things up. It's like how some people deal with email as it comes in, and some people every hour or two go and process everything, right? It's the same way with developers. Different people work in different ways, and you want to have that flexibility, especially when it comes to your own personal developer and development environment, right? To make it work for you, and so yeah, I think it's important to have that flexibility, and also to recognize it's really hard to mandate things like that, right? Like you must use this IDE with this configuration. Like, how do you even enforce that, right?
People try.
Right. It's like, people who create code for a living can probably be pretty good at finding ways around, mandates, right? So, yeah.
No, I think that's a really important point, is from my perspective anyway, as a consumer of tools like this, is that they're there to make my life easier, not to beat me over the head with a stick.
Yeah.
I mean, I think you probably share the same view.
Should have, sorry, what?
I think you probably share the same view.
Yes. Yes. That's right. Gentle nudges go a lot further than, gates and hammers. Yeah. Yeah.
So are there any other metrics that you'd recommend people look at if they're trying to just, improve code quality overall?
Yeah, yeah. I think you know, there's I I think it's useful to track, sort of notions of coverage and complexity and so forth. I think honestly, that's sort of one of the areas that's ripest for innovation, and is sort of like how you can get better insight into that, because it is like um, you know, it's super important in terms of reliability and maintainability and readability and so forth. These architectural decisions about how you abstract code, how you design things, where you how you set up your APIs, where you set module boundaries and so forth. And some of that is captured by things like code complexity metrics. It gives you some sense for whether a function is too big, or the scope is too big. But there's more to it than that. And I think yeah, there's a lot more that could be done there. And we're certainly exploring what can be added. Um, I think lines of code used in the right way can be useful. Like, you sort of know, like, our favorite. So we track, like, sometimes we'll give awards, for like the best for this sprint, our favorite merge request, right? What stood out, and for what reason. And one of those recently went to the merge request that removed the most code, right? Because that was it's very important, right? We were switching from one database to another, and so all the code that was talking into the old schema and the old data store was not needed anymore. But like, the easy thing is just to leave it in there, right? And you feature flag it, and it never goes away. And like, I think you got to celebrate those things, and metrics can help you recognize when that's happening, and make sure that it is happening.
Well, for me, one of the things I'd look at is lines of code delta as risk. So
Yeah.
the delta between where production is and where the rest of the flow is just plus or minus. That's just risk.
Yeah. Yeah. I think that's right. Yeah. And yeah, it's yeah. I think the other thing that's really interesting to me is production metrics, and what you can track in production, and tying that back to development. I think there's a lot of cool stuff happening, for example, in the performance monitoring space, right? Application performance monitoring in production, and you can sort of do some of that in CI, on the develop, sort of left when it comes to testing, performance testing and things like that. But drawing that line more brightly from production data back to development is something that I think is really interesting. And I hope we see, sort of some innovation in that space over the next few years.
So, I mean, hopefully this has been really valuable. What would you leave people with? What do you think that people should just really focus on next?
Yeah, I think, I hope that people continue. So there's definitely, I think, been a trend towards developers getting more ownership of, we talked about their development environment, but also, ops, DevOps is all about this, right? But, owning more of the process, and that being reflected in the tooling that's available, right? And so tools are, more and more sort of developer focused, meant to be owned by the development team, deployed by the development team, and maybe they serve other purposes as well. They're attending to security needs or performance needs or whatever, but they're targeting the development process, right? And I think that's going to. I'm really excited to see that trend. I hope that trend continues, and I think what I would leave people with is at an organizational level, some organizations are definitely farther ahead than others when it comes to sort of developer ownership of some of these key concerns. And so, I'd encourage people to explore that, as part of your DevOps transformation, or wherever you are in that, be thinking about how can you take some of your security or compliance or audit requirements and sort of introduce them more smoothly into the development process, right? So that it's not just some separate thing that, the code hits, before release, like it ultimately, like it improves productivity, it improves flow, it improves that delivery cadence, because everything becomes more predictable, right? As soon as things are integrated into the development process, you get to take that incremental approach, right? And see, this small change I'm making, how does that impact my requirements from an audit perspective, or my requirements from a security perspective? And so I think it's super valuable, even if your goal is just to ship software faster, right? It's something everyone needs to think about.
No, it's got to be fast and safe. So I agree. The more we can do that, the better off we are. Where can people, read or see more of your stuff?
Yeah. So, definitely you can go, if you want to try the Muse system and see, what I was talking about, some of the, approach to code analysis, that's up on GitHub. You can look on the GitHub marketplace for Muse, and it's, you can just easily install it, try it out. In terms of like the research, I think there's a lot of what I've been talking about, the importance of how you integrate things, the importance of, developer ownership of things like security. Like there's some cool work that Google and Facebook did in this space 5 or 6 years ago, when they were sort of experimenting with, how do we make static analysis more effective, right? We've done these experiments where we take some tool and we do some scanning offline and we create this bug list, and then we have a hackathon for a week where we try and fix everything, and it's like, doesn't work well. It's not part of the process. It's not effective. And so, what works better? There's couple of communications of the ACM articles. If you search for like Google static analysis or Facebook static analysis, you'll find those. And I think, those, at least for me, are the starting points for really the right way to integrate these tools into the development process. And so I'd encourage people to go check those out.
All right. Well, Stephen, thank you so much. I always enjoy talking to you. It's always fun to compare notes and to rant a little bit at people.
Yeah, same here. Same here.
Thanks again, and we'll be back with another talk.